would like to introduce our exceptional speaker for today. I say exceptional because we're going to be addressing a relatively technical topic today. And we have somebody who comes with, sorry, Shorai, but almost 20 years of experience already. But not any kind of experience, really very interesting because Shorai has started his career in the manufacturing side of modules, even like setting up of manufacturing plants, if I'm correct. But Shorai, maybe you will be able to address this topic a little bit more in details. Mm-hmm. And then more recently, you have moved into the more commercial aspects of things, really helping customers, analyzing their needs, and really guiding them towards what is best for their specific project requirements. So very interesting topic, very interesting speaker, and I'm going to hand over to you now, Shrai. I'm going to give you the controls so that you can share your presentation. And while doing so, please do not forget to tick that special box for the sound. Okay. Over to you. Yes, so your presentation is showing now. Very good. And you can go in presentation mode. Wonderful.
All right. Yes. Thank you, John, for giving me this opportunity, the platform, and thank you all for your time. Due to the limitation duration of this session, I won't be able to cover all the topics and demonstrations in detail. But however, I'm more than happy to continue the conversation and provide further insights. You can also contact me on my email. I think also John will share. And also
yes.
You can also get me on LinkedIn. Additionally, we offer also physical training sessions across Africa, which can be also arranged accordingly. You can also contact us here. So without wasting time, my name is Shorai Chataurwa. Yes, I'm the product manager for LONGi for the African market. The first part, I'm just going to introduce the company. The company was founded in 2000, and LONGi is committed to the most compelling solar technology company by leading the world's transition to green energy, focusing on customer value, propelling the transformation of energy in all scenarios. So what we've done, we've dedicated ourselves to technology innovation, established also 5 business sectors covering from mono-crystalline silicon wafers, mono-crystalline cells, and also module distributed photovoltaic solution, utility plant system solution, and hydrogen equipment. Eventually, we are going to be also supplying green power, that is a green hydrogen product solution for the global zero carbon development. So this is just a business introduction. I've just mentioned about the 5 business sections we have. I'm not going to dwell more on this. I want to go deeper straight into the technology we have. But I have to show you our manufacturing facilities. So LONGi was selected as the global lighthouse factory by WE, that is World Economic Forum, which actually makes us, because we lead in the high quality development of PV industry. So LONGi Jiangxi Lighthouse Factory has built over 30 digital use cases, achieving 43% increase in production quality reliability, and 84 reduction in production and delivery cycle, and 20% reduction in overall unit energy consumption at the base, becoming a model of high quality development in the photovoltaic industry. which encompasses the intelligent human resource management, that is ensuring the optimum arrangement of order demands and human resource. Then also we have flexible automation with more than 90% automation rate of the entire line to ensure high quality output. Then also what we've integrated what we have the one that is AI, artificial intelligent quality inspection, accurately identify 1,000 image features on the cell string, precising traceability, accountability. Then end-to-end delivery system also is incorporated in the factory. That is 80%, actually reduced 80%, 84% in production and delivery cycle time to ensure reliability delivery. Then the last one, that is AI, that is artificial intelligence distribution of solar cells, which actually become the first AI intelligent cell production solution calculation system realized accurately customers delivery. That is the LONGi factory. The next slide, this is just to show. This is the factory where we produce our product, our premium products. Then the third one is one of our flagship technology, which actually we introduced what we call the tire wafer. Now we're going deeper into the technical and technology development, which we have deployed from LONGi side. So we have tire wafer. Tire wafer it's a silicon wafer which we have developed throughout the last 10 years, and it does have a lot of advantages. That is your beta matching. I'm going to explain also further. Then also high concentration. I'll explain. Then also lower impurities and more impact resistant. So let's dive into beta matching. So beta matching is actually just the cell adopts to the optimum resistance. That is the material which actually made the cell itself. So if you look at the graph which I've put in front of you, you can see the comparison between the conventional wafer and also the tire wafer. So it does have a beta matching of best resistance compared to the conventional. Then the second one, that will be your high concentration. So that is the resistance distribution is more concentrated, reducing the risk of mismatching. Those who understand the mismatching of the cell when we produce them from the manufacturing. So if you look at the different curves, comparison between the conventional wafer resistance range and also the tire wafer range, you find out that the tire wafer range it's much better and it performs better. Then with regards to the low impurities, so during the manufacturing, we actually looked at the doped atoms and also silicon atoms, then also the ion atoms. So we gelled together to make sure that we reduce the migration and activation energy of impurities and better gathering performance of the cell itself. Then the last one, which is very important, is more impact resistance. Actually, we strengthened the wafer. So our wafer is more stronger. It actually resists to mechanical strength by increasing it by 16%, which is less prone to cause breakages and also micro cracks during transportation, during installation, and also during just merely handling of modules. So then my next slide is just a demonstration, as I'm going to showcase the wafers, comparing the two between the conventional and also the tire wafer we have introduced. So I'm going to play this video just to show the difference. So this is the silicon wafer load testing. So we're comparing the conventional and the tire wafer. So we used 50 grams standard weights on top of the silicon wafer. So you can see total placed mass of 400 grams. Conventional silicon wafer cracked while the tire wafer could withstand. So it actually demonstrates the strength of the tire wafer. So my next demonstration is our new HIMO X10. So the new HIMO X10 actually adopts the peak of silicon solar cell, which is the first choice for value. And actually, it adopts what we have just seen. The core of this module, it does have the tire wafer, which was developed by LONGi, and also it's produced under what we call the HPBC 2.0, which I'm going to speak about it also in my next slide. So why do we go and do development and come up with all these type of technologies? Is for us to solve problems. So after we have gone through around and do our research, and that's when we came up and developed, because we have found that there's a lot of issues, whether it's in the installation field or rooftops, etc. We've got a lot of issue, like, for example, shading and hotspot. They become core challenges for safety and also efficiency in terms of operations. So we looked at the frequency of shading, hotspots problems, which actually threaten the power station safety and return on investment. During our research, we find out that nearly 50% of module failures are caused by shading. So shading, it can be from the rooftop equipment shading, that is your fans and also other floors and also attics, etc. Then the second one, also surrounding shading, which is your buildings, your tree shading, etc. Then we have dust and also scale shading, which is dust and also, like, for example, soiling. So after we looked at that, then we looked at the distribution in terms of module failure cause. You find out that the large chunk of the problems is hotspots, shading and soiling of the modules. So we came and said, okay, let's look at it. Then we looked at also other parameters, for example, your delamination, your defect backsheet, snelling, PID, glass, and also EV discoloration. And also we looked beyond other impacts, like, for example, improper installed modules. So after putting everything together, that's where we came up with the solution, and we came up with a product that is your HIMO X10, which can solve all these issues, which does have an advantage over most of the products you find on the market at present. Let's look at now the shading. What does it do? What is the impact of shading? What is the risk of shading? So shedding have got a serious impact on the stability of operations of module and also your system. So first, it actually reduces your power generation. So shading drastically reduces module power generation efficiency. Then the second one, that is your aging. So it actually destroys your module encapsulation material, which actually accelerates your module aging. Uh, when we talk about encapsulation material, sorry, we're talking about the material we use inside the module. For example, your EVA. Recently, we have a premium product, which is your POE. These are thermoplastics, whereby it has to protect the cell from aging or from water ingression, etc. Then we looked at also the safety hazard, that is your hotspots, which may cause fire and other safety accidents. Then the other also the impact is increasing your operations and maintenance. So this actually increase frequency of operation and maintenance, which actually also increase your electrical cost. So thermal X10, let's look at the safety of it, as then ultra high. Yeah, so as I just mentioned, why we came up with the product and the advantages of this product. So I've got the cornerstone of station, what we've looked at as the hexagonal warrior in the industry as the HIMO X10. So we looked at the material. I just spoke about this briefly. We looked at the material that is what we have deployed in the product, that is a comprehensive and rigorous material selection and importation. Then we looked at also what we call the structure of the cell and the structure of the module as well, compiling with the system level mechanical stress resistance and the standard, which is we follow the standard, which is comprehensive quality control system standard. Then in terms of functionality, I've got two items, which is very important for this product, that is preventing localized overheating. Then the second one is full scene aging suppression, which I'm going to also talk about it. And manufacturing also, I've spoken about the Lighthouse factory, which is incorporated with AI to avoid human error. Then the last one is the test. So we actually deploy a full scene reliability system, standard testing. So if you compare now all these two competitors, you can actually that we have reduced failure risk by 45.2% when we introduced the HIMO X10. So we have done also, I've put some just kind of scenario on your right screen that is preventing localized overheating, because I know people will have some questions on that. So we did a comparison with TopCon and using thermal imaging. So you can see we've got the highest temperature of 136 degrees. That is when the module is in operation. And if you look at the HIMO X10, the highest temperature, it could reach around 98 degrees Celsius. So this actually effectively reduced the localization of high temperature and the risk of failure. Then the second one on the function, that is your full scene aging suppression. So our module, the HIMO X10 can actually withstand, scenarios whereby you have humidity and heat. So we've got also the products which actually can withstand this scenario. Some they call it anti-humidity and heat products, and also we have high UV, so the module can actually uh, 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 it can actually resist ultraviolet environment and also high temperature different. So this actually combats the multiple environment stresses, which actually reduces the reliability risk on your plant or on your system. Okay, some people they ask me, okay, what is this HPBC 2.0? So the HPBC 2.0, it just stands for hybrid passivation back contact 2.0. The previous product we had with HPBC 1.0, which was made of a P-type cell. But now the HPBC 2.0 is made of N-type wafer and with the core of uh, uh, the tire wafer. So this makes three key technologies. That is your BC platform plus bi bipolar hybrid passivation. I know many people are going to ask about bipolar hybrid passivation. I'm going to also try to explain it in a nutshell. Then also we have the tire wafer core. I've already covered this. I did it deliberately to start with tire core because it forms the core of the product. And we have also what we call zero BB structure. So in terms of these three leaps, we have the leap of cell technology barrier. So we upgraded the three-layer structure of the light absorption and also improved the photovoltaic conversion, then also electric transmission when we moved all these the bus bar back to the back contact, and we leave the front actually exposed for high absorption of light. Then we've got also the leap of silicon substrate limitation. So this is where I mentioned about when we equipped with the tire wafer core, then also which actually gives an enhancement overall power generation potential and reliability. Then the third one, we have the leap, that is the BC manufacturing dilemma, whereby we actually uh, did an innovation of developing a zero BB structure. So what we have done, we have removed the bus bar at the back of the cell also. Then we connected all the all the ribbons straight directly to your fingers. Then also we have also introduced the breakthrough of key processes and materials which you have chosen. So in terms of HPBC 2.0, we've got a mass efficiency of 26.6%. That is your last generation of crystalline silicon cell to achieve 1% leap in absolute efficiency. It's actually closest to the theoretical limit of 29.4 for mass production cell. So I think this is just a good choice for the customer, best choice for performance, reliability, and also aesthetics. Because if you look at our product in terms of the looks of it looks beautiful. It's aesthetically pleasing. Then the next section is I'm just going to try to break it down a little bit in terms of the self-developed bipolar hybrid passivation. So when we introduced the hybrid passivation, actually we've seen a boost of VOC and also uniform passivation actually reduce aging risk, which I just also mentioned in my previous slide. So bipolar, it comes from bubble. So when we moved the busbar from the front, the connection from the front to the back of the cell, so we have what the positive electrons, then we electrodes, then we have also the negative electrodes. So the previous modules, we used to have one passivation layer on one electrode. So now what we have done, we've introduced a double. So for the positive and negative, we've introduced what the passivation on both. Um, so when we did in an experiment, we might find out that the passivation uniformity is 2% ahead of the mainstream product, which is actually effectively against the UV and also to the cells. Then we have also the advantage is the passivation also reduces current loss at both positive and negative electrodes. So by placing both, that's where the name came as bipolar. So bipolar hybrid passivation, that's where it came from. So if you compare now with the top cone have got a higher temperature in terms of boron diffusion, which actually leads to an even passivation layer and also the formation of leakage channels, which is prone to failure in ultraviolet environments. And also it uses unipolar passivation, which just they have also high current loss. So in a nutshell, bipolar hybrid passivation process boosts open circuit voltage by 15 millivolts plus, and in terms of mass production, voltage exceeds by 745 millivolts, which is comprehensively improve the cell efficiency and degradation performance on these PV cell, which is also produce the X10. So I've got a video here just to demonstrate the substrate advantages, which I'm going to talk about, which is a comparison between TopCon and the module. As you can see that there's a greater advantage in terms of these modules. So I have already broken it down so that people can understand exactly what we speak about. So this is an exploded view of the cell itself. So if you look at the front of the cell, there's no bus bar at all. Then if you look at the middle, we have also the passivation, that is which actually improves your photovoltaic conversion. Then also the backside, which actually improves your transmission. So we optimized by multiple layer by putting also an anti-reflecting film, which actually increased the light absorption, and I've put the numbers there, which was also tested by third parties. That is 2.25 increase in short circuit current and 12% plus reduction in reflection at short waves, because you can see there's no reflection, the bus bar is clean the front. But then also the self-developed bipolar hybrid passivation. I mentioned also mass production VOC, it increased to 7 effective against UV induced degradation. Then we have what we call the soft breakdown design plus the bipolar low resistance passivation contact, which actually reduce fading power loss. Overall cell efficiency improved also on these cells of ours. Then the most important as well advantage of our product. I think that many people they've seen going adverts in terms of the anti-shading, and some they ask questions, what is this anti-shading? So our modules, we have deployed an anti-shading feature to actually curb the issue which I just mentioned in terms of When you install your modules, there's a lot of issues. For example, equipment shedding, there's leaf shedding, there's also dust shedding, snow shedding. So if you look at the Hamo X10, if there's one cell shedded, it won't affect the whole string compared to the conventional module on the side. So single cell shedding leads to self bypass. So there's no effect to the power output of the entire string of cell. So less loss, less power loss, and if you compare now to the conventional module, the moment you block one cell, whether it's leaf or it can be bed droppings, you will have the whole entire string get affected. So single cell shedding leads to the entire string of the cell to bypass. That is your large power loss. So in the case of one cell shedding, in a nutshell, the power loss is 70% less than that of the TopCon modules. So this is just a video which I've also did demonstration just to showcase this phenomenon. So TopCon versus HPBC 2.0, that is your Hamo X10. Yes, if you look at the TopCon, you find out that if there's any leaf dropping, it's just self-explanatory. There's a 35% reduction in module power generation efficiency after one piece of this cell is shedded. And if you look at the HPBC 2.0, that is your Hamo X10, using equivalent built-in bypass diode technology, only 8% reduction in module power generation efficiency after one piece is shedded. So Hamo X10 have got a higher advantage in terms of the comparison between the two. So this is just also to look at the safety of the module. I've spoken about prevent localization overheating, which actually eliminate fire hazards. So the design which I just mentioned, also innovation software breakdowns design. Actually, it's like you're buying a fire insurance for your roof, because even if the probability of 1 in 10,000, once a fire occurs, the power station will suffer huge losses. So the innovative software breakdown function of Hamo X10, it's equivalent to buying, for example, 30-year fire insurance for the for your rooftop power station. So this is just a comparison. If you look at the Hamo X10 and also TopCon, that is the difference here. So this is just also in terms of demonstration as to HPBC 2.0. It's just some short videos which I can also share with the attendees in comparison, just to highlight this built-in bypass diode. So disaster can be effectively avoided when you compare the two. Then the localization of heat, you can see this is the difference when it comes to localization of heat. So this is the comparison between the conventional module and the Hamo X10. This is your TopCon Hamo X10 module, and you can see after blocking, then you can see the temperature difference. All right. I think the comparison is actually self-explanatory. You can actually see that the HIMO X10 have got advantages. Because of time, I think I'm going to move a little bit uh, faster. So this is the product range of our HIMO X10. So this is the first choice for high-value modules in the global DG market. So we've got three lips. I'm just going to go through all the products we have. So in terms of the maximum conversion efficiency, we are looking at 24.8%, and the maximum module power is 670 watt peak. So across the range, we've got 54 cell, which comes with a dimension of 1.8 by 1.134 millimeters. In terms of the power range, the power bin, we're looking at 475 to 505 watt peak. Um, then in terms of the 72 cell module, it comes as standard. We've got a 2.382 by 1.134 in terms of the dimension. The power bin is between 630 to 670 watt peak. Then we have the 72 bifacial, which also have the same dimension with the monofacial, but with a different peak in terms of the module power, which is 625 and 665 watt peak. Temperature coefficient, you can see our temperature coefficient plays a very significant role. It's sitting at minus 0.26% per degree Celsius, and annual degradation power is 1%. And from the second year going to the 30th year, it will be 0.35%. Then we look at the 15-year warranty. That includes also that is your manufacturing workmanship. Then we have also a 30-year warranty, a power guarantee, output warranty. Then my next slide is just the demonstration in terms of uh, the advantages in terms of the bill boss. So this is cost saving analysis per watt, which we have done the analysis, but we have done this with the size of 2.382 by 1.13 under the same length, area, and conditions. Then the numbers don't lie. You can actually see there that you have an advantage in terms of module installation. So there's you have an increase in installation capacity. Then in terms of inverter and also installation, you actually have cost saving. Then also in terms of the land area, we've got cost saving comparing by Topcon and the Hammer X10. Then the next one is and the simulation which we have done here in Cape Town, South Africa, with a roof area of 14,000 square meters with an angle roof of 3 degrees. So the system design was 22 pieces per string and a total of 160 strings. So we used 11 inverters of 175 kilowatt system. And as you know, our modules are high voltage. So the system voltage was sitting at 1,500 volts. So after comparing all the numbers, I'm not going to go through all the numbers. Uh, the result is there was an increase, 8% plus increase in power generation from the Hamo X10. So this is also the power generation comparison. So this is just a simulation average data of typical region around the world. And you could see there is an increase of 8.7% increase in power generation. So uh, looking at the investment residential, we've got investment higher returns. Because of time, I'm not going to go through all the numbers, but the numbers, you can see that we've got uh, advantages, and we've got also uh, higher return on investment. Same applies to the next, to the CNI, in terms of a levelized cost of electricity. So this is a scenario which we have done for Xi'an, and with the also similar roof, and also in terms of self-consumption of the CNI electricity. The system design was the same, and you can actually see that there is also installation capacity increase, power generation increase, your internal rate of return, that is your IRR percentage, also increased. Then you've got your LCOE, that is your levelized cost of any electricity. It's actually decreased by 6.9%, which makes the module much favorable in our uh, environment. So I think that will be it for today. I think I've already gone uh, beyond time. Thank you very much. If you have any questions, maybe one or two, we can maybe uh, uh, tackle it. If we cannot, then I think, yeah, I'll share all my details. They'll share all my details to you all, and I'll be able to answer your questions and maybe get some support. Thank you very much.
Thank you very much, Ray, and congratulations with your great presentation. I don't know, maybe you invited your entire family or you have a lot of fans, but there were a lot of very positive comments about your presentation today. Very insightful technical presentation. That's just one of the many messages that we have received.
Thank you.
What I suggest for before we take on a few questions is maybe you can stop sharing your screen so we see you in full mode together with me. There we go.
Yes.
And maybe I'll start with a few questions of mine because I feel I've learned a lot today. Thank you very much. I'm not the
Yes.
most technical person out there, but I'm always learning something new. My first question was about your the first video, and thank you very much for all these great videos because they make it more lively, they make it more tangible, really, to understand the different aspects. In one of these first videos, there was a comparison with weight going on the product, and so obviously this was to demonstrate that there was more resistance. But in reality, nobody ever puts weights like this on panels. So why is this important exactly?
Okay. Yeah, so when you're doing the construction of the module, the most important is your wafer. So your wafer strength determines the strength of your module. I think you heard a lot about micro cracks during transportation or maybe during the installation. So if your wafer is not that strong, and if your wafer is not strong enough, it's prone to micro cracks. It's prone to cracks. Yes. So, for example, we've seen a lot of these things happening, modules being dropped while they are doing installation, and also some installers, you find them walking on top of the panels. I'm not saying that you can walk on top of our modules, but um, our modules can resist. They've got a higher resistance to all those micro cracks. So we used a premium, a self-developed wafer from LONGi, which we call the Tire wafer. Yes, which falls under the HPBC 2.0.
Thank you very much. That's very clear. Another topic that you addressed during your presentation, you mentioned several times about hotspots and localized overheating. Just to make sure, are those two concepts separate or are they actually interrelated?
Yeah, in reality, you find out that these come hand in hand. But the way we have designed the module, it actually avoid both at the same time. But the cause, it can be the same because the cause, it can be shading. The cause, it can be anything which actually blocks the cell from doing what it's supposed to do. That's why now we have self bypass diode. And so it's not like a diode itself, it's a structure of the cell itself which we have developed, which actually prevents these two factors.
And in case something like this is created and exists, is there any way for people actually using or having a solar installation to actually identify this before it's too late? You showed a very cool video where people were creating shadow and then measuring with temperature guns, and but in reality we don't necessarily have this. So how can people who already have an installation know if they are exposed to such a problem or not?
Yeah, I think the first thing, if we have this problem, the first thing you see is the generation of your plant. The first thing you find you have problems with your generation. Then you look at now the product itself. You just do your failure modes and try to find what is the issue. That's when you now deploy, for example, thermal imaging. Then you find these kind of issues, for example, your hotspots and also localized of heating due to the blockage. So us as LONGi, we have managed to solve this issue by introducing all this innovative technology in our modules.
Thank you, and thanks also to Dr. Francis to give a bit more information also on this topic of hotspots and overheating in the chat section. I have a
Thank
question
you.
from Ali from Dubai, who is asking, is this product already being used? And in this case, specifically in Dubai. Obviously, the question, we know that Dubai can get very hot. There's also this aspect of soiling, which is also very important in arid areas, like might be the case in Dubai. So maybe I'll open up the question a little bit, like, is this product already available anywhere or only in specific countries? In Africa, in this case, in which countries? How does it work?
Yeah, so the product itself is now available for global market. As we are ramping up production of this product, it's case by case scenario. Yeah, but it's also available in Dubai. I encourage for them to contact our office in Dubai. They will do all the arrangements to make sure that they get the product. So this is globally. It's available globally, and we've already started ramping up the production and also optimization of efficiencies as well.
Thank you. And then maybe extending on this topic of dust and cleaning, we had a question from Duro, who is asking specifically about this in the case of an installation close to a cement factory that generates a lot of dust. And the question of Duro is asking, well, obviously this is potentially a problem. You've highlighted it also in your presentation, and is asking about any new solutions, any new services that you may know of and that you can share about with us.
Yes, that's why I was saying that we have. I didn't have much time to give everything. We've got all the solutions. We've got the anti-humidity and heat solution and our guidance series. Then we have also the dust-free modules as well. So these modules they're available also under the X10 flagship. It's self-cleaning. So what we have done to these modules, we've actually changed the profile of your short frame to flush with the glass so that you can have easy self-cleaning of the module. Yes, during maybe rain season, even just cleaning. By so doing, it actually also helps you in terms of your O&M cost, that is operations and maintenance cost, and also generation of your power will be also be an added advantage as well.
And then still a little bit expanding the topic of today, but we're just making use of your presence because of your long experience with this. Douglas is also asking about your opinion on flexible silicon panels. Are they any good, or is there still like a limited number of uses for this? What's your opinion on this kind of technology?
Yeah, for me now, as I'm in charge of Africa, I'm going to talk more about Africa because each region we have different requirements and applications. Regarding Africa, I think it's not it's not common flexible panels because also remember our environment it's price sensitive, so we must try by all means to cater for that. So I don't have much insights with regards to the flexible panels across globally. Yeah, but in Africa, definitely we are still going on with our rigid panels and yeah, our standard cell.
Thank you. The next question is from Abdullahi. He's asking about ARC, anti-reflective coatings, or also mentioning light trapping structures. He's asking about the latest you can tell us about the improvements and the solutions that have been implemented by LONGi, and more generally maybe in the market a little bit what's going on and if there is anything new that can be expected.
Yes. I'm going to speak about what we have done to our product. So, in a nutshell, just I just mentioned about the cell itself. So, if you compare now the cell structure itself during manufacturing, we have the surface of the module. So, on the surface of the module, we have uh, the pyramid structure. So the pyramid structure on top of the cell is to trap the light and to make sure that you increase your absorption. So from LONGi, what we did now on the X10, we actually included what we call the sub-macro structure on the cell. So so you trap more light. So we try by all means to protect light from escaping the cell, so thereby generating power. So this is what we have done. So it's a topic on its own of what we've done to the cell. Then also what we did also to the whole product as well. We have also anti-reflecting glass. That is number one. Then we've got also anti-glare and glit product as well. So if you want to, for example, you want to install the modules close to the airport where there's these regulations of reflection, etc. We have the wide range of these products. So it's case by case scenario. But if you come to, when it comes to the Hamo X10, it actually solve all these issues and Yeah, and we can spend the whole day talking about it. But I think if possible, maybe we can also have one-on-one session, or people can also DM me directly. Then I can share the information.
And I think this will be the case because of the few questions that are following now. Let's do three more questions because I'm also conscious about the time. But those are three very interesting questions, in my opinion. First question from Amanda, who was listening in through LinkedIn. She's asking if LONGi also has developed a range of storage solutions, because this is true that we've seen a trend in the market from companies that were traditionally pure module manufacturers who have also developed a range of very compatible and very easy to plug in solutions with regards to storage. Is this something that LONGi also does or is planning to do?
Moment, we are not doing storage solutions. In terms of planning, I don't have that kind of information, but we can go back and find out from the headquarters what is the plan. Yeah, then I can share directly with Amanda.
Very well. In any case, we'll share, we'll put everybody in touch after this session.
Yes, correct.
Then another comment slash question from Dr. Francis, who is in charge of a research institute and training institute, um, doing research and testing on a variety of solutions and applications. And I think it will be a discussion that you can take on a one-on-one basis. But he's obviously interested in investigating if there is ways to partner up with a company like LONGi and to expand the training that they are giving to students. Dr. Francis, I suspect this may be located in Ghana, maybe, but if you can just confirm in the chat, that would be great. And then finally, the last question that I would like to ask you, which is a question that I've received from different people. It's they're asking about, of course, the availability of your product in all across Africa, but also about your team and your offices. Yes, of course, they will be able to get in touch with you, but maybe you can tell us a little bit about how your team is structured and where you have representation all across the continent.
Yeah. So in terms of Africa, we've got all representatives across West Africa. Then we've got also East Africa. Then we also have Southern Africa. Then our office is it's in Cape Town. Yeah, that is our representative office for the whole region. It's in Cape Town. But just feel free to reach us. We'll directly to the right people. We can actually assist you in whatever you need. But with regards to all technical questions, and also maybe collaboration in terms of technology, yeah, I'm here. You can contact me anytime. We can discuss. We can come up with different solutions as well. And also to the students, we can also share some kind of insights in terms of technology. Thank you, thank you, Joe.